The title of this problem is Following Directions and it is from Codeforces. Here's what it says. Alperen is standing at the point 0, 0. He's given a string S of length n and performs n moves. The ith move is as follows. If Si equals L, then move 1 unit left. If it is equals to R, then move 1 unit right. If it is equals to U, then move 1 unit up. And if it is equals to D, then move 1 unit down. Then it says there is a candy at 1, 1, that is 1 unit above and 1 unit to the right of Alperen's starting point. You need to determine if Alperen ever passes the candy. Input. The first line of the input consists of an integer t, the number of test cases. The first line of each test case contains an integer n, the length of the string. The second line of each test case contains a string s of length n, consisting of characters L, R, D, and U, denoting the moves Alperen makes. Output. For each test case, output yes without quotes if Alperen passes the candy, and no without quotes otherwise. You can output the answer in any case. Great. So, as always, we are given the number of test cases and then each test case description. So now all we really care about is this string and the shape because that string will give us literally the way that um, that Alperen makes, or sorry, the way that Alperen takes. So let's look at this image closely. Let's say, for example, it says Alperen's path in the first test case. And here we can see the first test case is 3U's, then R, D, D, L. And you're going to be able to see it right here. So let's think about it. It says Alperen is starting at the point 0, 0. So it means that in each test case we will start at that point. So let's look at this image. Here we are starting at the point 0, 0, and this will follow the string of the first test case. Let's say the first direction or the first instruction is to move it's the letter U. So that means if you think about it, the this is a coordinate plane. So the coordinates of our starting position are x0, y0. And because it is a letter U, that's the first instruction, so to speak, all we have to do is take the current value of y and add 1 to it. So that means instead we go from 0, 0 to 0, 1 because 0 plus 1 is 1. So our new position is 0, 1 and it repeats itself. We go to 0, 2, then 0, 3. And here on the fourth instruction, the thing changes a bit because now we get an R. And this means that instead of uh, changing the value of y, we now have to change the value of x because we are moving horizontally, not vertically. So that means that if we are at the point 0, 3, then we just take the current value of x and add 1 to it, resulting in 1, 3. And then we go back to moving um, vertically, meaning changing or interacting with the value of y. So that will mean it is this time for the value of d, it would mean to take the value of y and instead of adding 1 to it, we will subtract one from it. Meaning if we are at the point 3, 1, no, sorry, we are at the point 1, 3, then we take the 3 and subtract 1 from it, and we now would be at the point 1, 2. And then if we repeat that same operation again, as per the instructions, we would end up, uh, in this case, at the point 1, 1. And at that point, or in that moment, we are done because all we care about is if if Alperen ever passes the candy, and in this case we have determined this is true. So at this point we can literally break the, you can imagine this will be some type of loop. We could break the loop and print out our answer, so to speak. So it's pretty straightforward. We're going to iterate over the string, and we're going to map each of these letters to literally an addition or a subtraction to the corresponding x or y values. And that's pretty much it, really. So let's do that. And yeah, let's start with the test cases. I already have, sorry, I don't want you to see that. I already have the boilerplate for the test cases. Now we have to take n. We will take n, which is the length of the string, and then we're going to take the actual string. Let's say s, just like this. And okay, now that we have the string s, we can, or we have to sort of like establish our starting point, which in this case is going to be, we will always start at x0 and at y0, just like that. And now we can start iterating. For example, let's say we can do something like this to iterate over all the letters in this string, and we can start checking for those test cases. For example, we can check for the test case or the case in which the letter is L, and in that case, we have to move one unit to the left. So that means we would have to take the current value of x and subtract 1 from it, just like that. Then onwards, we have to check this time for the value r. If the character is equals to r, then we move one unit right. So it's the exact opposite of this. We take the current value of x and add 1 to it. Great. Now we check for the case of u, and it says move one unit up. Something like this. Sorry. And now we stop interacting with x and we start interacting with y. We would add 1 to y because we have to move up. Um, yeah, just like that. I'm vertically, not horizontally. And then we could do just else because there's literally only one case left, but I want to keep it consistent. So I'm going to stick with else if, and then we will check for D, which is the opposite of U. So let's just subtract 1 from the current value of Y. And now, after we have made our checks, we can uh, we can determine our solution, or rather, at any sorry, in every iteration, we will have to check, are we at the spot 1, 1? Because if we are, then we can end the discussion because that means we have reached the point which we care about. So let's do just that. If x is y and not like that, y is 1, we can, let's say we're going to start by default, the answer is going to be no. Oops, no, not like that. No. And only if this is true, if it's ever true, we can assign the answer to yes, just like that, and we could break out of this loop. And then after this loop is done, we just have to print out the answer, just like that. So let's give this a go, and let me grab the sample input. It says yes, yes, no, no, yes, yes, no. Yes, yes, no, no, yes, yes, no. So it's looking good. Let's submit it. Ignore this. And the problem is following directions. Let me grab the source code and let's submit it. It's taking a bit longer than I expected. So let's just be patient. Sorry about this. Um, yeah, in the meantime, I can tell you a bit. Okay, it's accepted. Great. So about time complexity, the time complexity of this would be O of n because we would have to iterate over the n characters inside the string s in order to check if we ever reach the point 1, 1 for this case. So hope that was useful and that's it.